I don't think the terms emergent and fundamental are actually super well defined, and I can just describe the general way that I've seen it being used by physicists. I think what most physicists mean when they say something like space-time is emergent or space-time is not emergent, it means something like that space-time continuum exists out there in some sense. It's almost like a container. Now, it's true that in general relativity, space-time is modulated or, curved by matter. But nevertheless, the models that talk about space-time as non-emergent imagine that, the matter may curve space-time, but it's still kind of out there and particles are kind of moving around inside it. There are many physicists who think, and I'm not a physicist, but I have a physics degree from Harvard. I tend to agree with the physicists who think that space-time is an emergent property. So in that case, what physicists mean by that is that there's some sort of ground reality that is outside, that doesn't have space-time as part of its intrinsic structure. However, that deeper reality is structured, it would not actually have, like notions of space and time and distance and intervals of time kind of built into it. The analogy I could make is imagine that you had a computer simulation of the physical world, and the actual, ground truth of the computer is, all these bits that are living in memory. It doesn't actually have space as a fundamental structure of that. But because of the way the software is running, it actually creates a simulation of actual space and distance, even though that isn't kind of built into the way that random access memory is structured in the computer. In most random access memory architectures, you can access most of memory about equally quickly, no matter where it is. You can jump from one place to the other. But in your simulation, you actually add more constraints so that you have a simulated object moving through this simulated space, and it might take time to get from one place to the other. But the underlying reality doesn't have that structure fundamentally inherent in it. The computer, of course, still has time. It is still clicking forward. So this isn't a perfect analogy. But you can imagine something analogous potentially might be happening in the universe, where both space and time are emerging out of a deeper reality. It doesn't have that as a fundamental part of its structure.